Hi everyone. How are you doing today? Great. I'm doing fantastic, thank you. Alright, I have a question for you students. What does a cup sitting on a table, a bouncing ball, and a Hot Wheels car rolling across the tabletop all have in common? Now we're talking about the movements of these objects, not the objects themselves. Very good guess. Good guess. Great. Well, Joey is right. It has to do with, for every action, there is an equal and opposite reaction. Newton's third law of motion, right? Now, how are we going to illustrate this? Well, there's one way of doing it, is with string, a straw that the string is threaded through, some tape that has been rolled up so it's sticky on all sides, and then a balloon. So let's see what happens. I'm blowing up the balloon. And I want it 10 inches long. Meaning I want it to measure 10 inches from where I'm holding the balloon shut to the end of it. And we're right there. So then we take the balloon. First of all, we attach the tape to the straw, then we attach the balloon to the straw through the tape. Make sure the straw is very straight. Okay, and then I've already attached the string to the wall. And now I'm going to bring the balloon over here, hold the string tight, okay, make sure it's attached pretty firmly, and then we're going to watch the balloon. Now it traveled a little bit of a distance, didn't it? And you guys in your labs will be able to measure that distance. But first of all, take out your lab books and sketch the forces, and I want you to sketch the string, the straw, and a blown up balloon, and then sketch the direction of forces that acted on it. And we'll talk about that right now. The balloon moved that way, so that was the direction of force, and then the air was to the south, right? So then we'll look at, I want you to sketch these 3 scenarios in your labs and then draw the forces, the direction of forces that are exhibited when a car is rolling across the tabletop, when a cup is sitting on the table, and when a ball is bouncing. Okay, next thing we're going to look at, we're going to review real quick the instructions, okay, for the lab. Gather your materials, thread the string through the straw, stick tape around the middle of the straw, blow up the balloon, make sure it's 10 inches long, stick the sides of the balloon to the tape that's on the straw, and then pull the string tight and pull the balloon to the very end of the string and let the balloon go. Measure that distance, and then you guys will be set to go. In your labs, you'll find that there's 2 different scenarios you'll have to deal with. Not only a horizontal string, but a vertical string. And I just want to make sure that you start the balloon at the floor, and then someone stands in a chair and holds up the string up high, okay? Now, I want you to view how this, I want you guys to come look over here. And this is the Wyoming State Standards, okay? Students, describe motion of an object by position, direction, and speed, and identify the effects of force and inertia on an object. So this lab has to do with motion and the directions of force. So that's how it ties in with that state standard. All right, you guys have your kits, you have your materials all set to go. Threading the straws is pretty easy. You just drop the string down the straw and get to it. I'll be walking around now.